Hello and welcome to this week 9 session on constraint and unconstrained optimizations in PTL course. So the agenda today will be to discuss the week 9 assignment solution and also some of the related problems that you'll find in week 10 assignment. Since it's around 3 minutes to 3 p.m., so I'll wait for say 5 more minutes and then I'll get started with today's content. Okay, so it's 3 p.m. already, so I'll get started with today's content. Hope people will join in sometime later. Okay, so I'll get started with the week 9 assignment solution. So I'll write down the problem and then I'll solve it. And some of the problems might be direct, so let's see how that looks. Okay, so the first problem tells you the steepest descent this steepest descent direction s of the function fx is sort of given as so the options are option A is for the minimization problem. So for the minimization of fx, S is grad of fx. Option B is for the minimization of fx. S equals minus of grad fx for the maximization of fx. S is grad of fx, and option D is for the minimization of fx. and S is minus of grad fx. So if you notice, option B and D are the same, so there is a mistake in this problem. And I think one of the options were chosen as correct, but the other one was not. But I think there could be some typos, so I would recommend you to raise this issue. I think you have already done that in the discussion forum, and hopefully the instructors or the mentee or the host will take care of it. Anyway, so the answer to this problem, option B is the correct answer. That means option D is also correct. And for the maximization problem, the direction will be exactly opposite. So option C is also correct. So the answer here is B, C, and D. But there is a mistake in option D. So it was supposed to be something different. So I'll just say raise this issue in the discussion forum. Alright, so that's all about the first problem, and I don't think I've explained the theories and all because that have been already covered in the lectures. So let me go into the second question. So it says that for the quadratic for a quadratic function, fx is half x transpose ax plus b transpose x plus c. The steepest descent direction S is are given as options are option A is S equals ax plus b, option B is S equals minus ax, option C is S equals minus ax minus b, and D is S equals ax. Since it's a descent direction, it's a minimization problem. So let me solve this problem. So first what we have is fx equals half of x transpose ax plus b transpose x plus c. And then you take the gradient of it, and you can verify that it will be just ax plus b, and s is nothing but minus of this grad fx, and that is minus ax minus b. So your answer is option C. So that's the correct answer here. The answer is C. So I don't think there was any issue with this problem. Okay, so let me try the third problem. For a quadratic function, fx equals half of x transpose ax plus b transpose x plus c. The optimum step length is asked in this problem, and this has also been proved in the class, so I will be going into the proof of it. The optimum step length lambda is given as A is lambda equals S transpose A, sorry, S transpose S divided by S transpose AS. Option B is lambda equals minus S transpose S divided by S transpose AS. Option C is lambda equals S transpose BS. And option D is minus lambda equals minus S transpose AS. So as in what, this option A will be the correct answer here. Option is the correct one. So we have the theoretical this proof-based problems that have been already solved in the class. Okay, so let me go to the first one. So that's also very easy kind of thing, but theoretical questions. So if xi plus 1, xi plus 2, and points let me just check if it is conversion. And there's 2 iterations respectively of the first descent method, then which of the following is correct? Yes. Plus I sine and 6 plus 1 are always parallel to each other. Sine plus 1, 6 sine and sine plus 2 minus 6 sine plus 1 always perpendicular to each other. Yes. Sine plus 1 minus 6 sine and 2 minus sine plus 1 are always oblique to each other. Option D is none of this. As you might be knowing that these should be perpendicular to each other, so that's the concept of a conjugate gradient as well. But anyway, and also this is the case in the steepest descent method. You take the differences between those factors and then consecutive iterations, and those factors have to be perpendicular to each other. So it's does exactly that you do to reach the optimal solution. Okay, so that's answer SD. So I think this is not an issue, and I just discussed in the class. Next is the fifth problem. So now we have double numericals. So apply the apply steepest different method. To normalize of x1 comma x2 equals 2x1 squared plus x2 squared plus 4x1 x2 minus 4x1 plus 2x2 plus 5 starting with x1 equals 0, 0. So the options are asking to find x2. So finally just selecting the option, then the option is x2 equals. Option C now tells you about x3, so you have to do two iterations here at least to check whether the solutions are correct or not, because there can be multiple answers to this problem. Okay, so I'll solve this problem, but also since there is not much topic to cover in this week, so I'll just wait for a few minutes and see if anyone joins. Then that will be easier for me to explain it to someone directly. If not, if no one joins, then I'll start solving it again. So I'll just wait for a few minutes. Okay, so let me solve this problem and why no one is joining, but yeah, I have to solve it. So let me check what is this function will. So I'll write the function again, and my starting point is 0, 0. So first let me calculate the gradient. Gradient would be, first you will take with respect to x1 to get the partial derivative. So it's 4x1 plus 4x2 minus 4. Okay, and this is 4x2 plus 4x1 plus, and you can write it down as fx1 x2 at 0, 0 was minus 4. So that means your s1 this case be minus of minus 4, 2. So this is 4 minus 2. And now what you can do is find out your lambda 1. So lambda 1 is, for a minimization problem, S1 transpose S1 divided by S1 transpose is AS1. Okay. So now I have to get A. So A you can get from the expression, and I think previously I shown you how to get this A matrix. So it's nothing but writing it in terms of half of x transpose AX plus B transpose X plus. Okay. And once you do that, you can find out. So this for corresponding to this and this will be 4 and 4. And for x1, x2 terms, those will also be there. So from that, we'll get this as 4 and 4 as well. Actually, you can find it out. It's not a big deal. You can always assume something that capital X and then you can proceed. Anyway, let's get into this. lambda 1 is 4 minus 2. 4 minus 2 divided by 4 minus 2. 4 so to that, it's 16 plus 4 is 20, and here it will be one, so that's 16 minus 8, so that's 8, and here also it will be 8. So it's 4 minus 2. It's 32 minus 16, that's 16. So once we have this, I think that is 5 times 4. Now we want to find out x2 value. So x2 is 1. Then we have those lambda. You can have it towards the negative of this direction gradient and take this. So this lambda times f minus epsilon. This is nothing but 0 plus 5 by 4. And here is 1 is 4 minus. Take 2 out of it. So if I take 2 down, so it's 5 by 2. And this is 2 minus 1. So let me check if this one's in one of the options or not. This will be 5 by 2, 2 minus 1. The option is the correct one. Now I have to also find x3 here. Okay, so let me try and find x3. So let me just quickly open it. Okay. So for x3, what will we do? So again, single a. Now let's get grad of this calculation of x3. So this is at this new point. This is at the point that you have is 5 no, minus 5 by 2. So this is 4 times x1 plus 4 times x2. It's 4. This is 4 times x2. 4 times x1 plus 2. What you have is 20 minus 10. That's 10 and split at 6. And then you have minus 10 plus 10. Okay, so you have 6 and 12 of your gradient. So it still becomes minus of this. Look at that, minus 6 minus 12. and for A involved, and it's simply the one that lambda 2, which is this 2 transpose S2 divided by plus 2 transpose H. So this is minus 6 minus 12. 6 minus 12. This is 4. This is 6 minus 12. Okay, so now I'm going to calculate. This is 36 plus 144 if I'm not wrong, so that's what I got. Next is minus 24 and minus, so this is minus 72, minus 72, minus 6, minus 12. Okay, so once you have this is nothing but minus 72 times 18. So you have 10 by 72, that's 5 by 36. So let me just check. 5 by 36, okay, that's interesting. So x3 is x2 minus lambda 2 times minus of x2. So we had 5 by 2, 1 minus 1 plus 5 by 36, and for x2 was minus 6 minus 12. Okay, so this is interesting. Let's see what would be the answer to this. It's 522. That becomes minus, and this becomes 5 by 6, and 5 by 3. Okay, so this becomes 5 minus 5 by 6. This becomes minus 5 by 2 minus 5 by 3. This becomes 25 by 6. Here it becomes 15 plus 3. So this is minus 25 by 6. Check. So this becomes, if you take 25 by 6 as common, so this is 1 minus 1. So I think option D would be also correct. Yeah. So option B and option D, those will be correct in this case. Okay, so the answer is option D. So that's all about the first problem. Now we're going to get into the sixth problem. Okay, so let me write down the problem again. Apply simplest assignment. x1 for x2 is 2x1 squared plus x2 squared plus 4x1 squared minus 4x1 plus 2x2 plus 5. So this is the same problem as before. Starting with x1 equals 0, 0. steepest deceleration. Yes, let's do this. Okay. One. So this is the first one actually. Sorry. Oh, S1 and S2 both are downstairs. So S4 is number 6 minus 12 and 2 is S2 minus 12 minus 6. So let's check what was S1 and S2. So S1 was 4 minus 2, so that means option A is correct. And S2 is minus 6 minus 12, that means option C is correct. So this is fine. So let me mark the answers. Option A and option C are correct. Yeah, so the answer is A and C. So that's all about the sixth problem. So that calculations are already present at the previous problem. Okay, so now let me get into the method of substitution problems. So there are a couple of them in this assignment. The seventh problem is maximize Z equals, just a minute, some issue with the internet. Okay, so this problem is 50x minus 2x squared minus xy minus 3y squared plus 95y. This is subjected to x plus y equals 25, xy greater than or equals 0. Okay, solve the optimization problem. by method of substitution. Yeah, 15 minus star star plus 15 again CS star star 17 DS star star plus 20.5. Okay, so this is great. Let's so the method of substitution is, so I'll just write it down. It's 25, that means y equals 25 minus x, and that is also greater than or equal. That means x is less than equals to 25, and you know that x is greater than this. And z, you can write it in terms of x only. So z is 50x minus 2x square, 50x minus 2x square minus xy minus 3y square plus 95. So now we have to calculate this. This is 50x minus 2x square minus 25x plus x square minus 25 minus 50x plus x square plus 95 times 25. Okay, let me calculate it quickly. Yeah, it's 2375 minus 95x. So once you do that, so you're left with minus 4x square okay, 55 minus, okay, plus 25 minus plus, okay, 25 50x minus 25x, so that is 25x. So that's 125. I think there is some mistake I have made. Just to note 50x, that's 25x. Oh, so that's 25x plus 150, so 175. So this is plus 80x, and then you have calculations is 2375 minus 3 times that thing, so that's plus 500. Okay, you can take minus 4 as common here, so x square minus 20x minus 125. So that problem becomes that that was a maximization problem, if I'm not wrong. So this part you can take. So min of x square minus 20x minus 125 subjected to 0 less than equals x less than equals 25. So this is the new optimization problem that you have to solve. and suppose this is gx. So you can take the first derivative g prime x, and this is 2x minus 20. You can set it to 0. That gives you x equals to 10. So that's within this limit of 0 and 25. So that's fine. And when we take the second derivative, it gives you 2 that's greater than 0. So that means you have minimization problem. So x is 10. So that's good thing. And y is 25 minus 10. So x star y star becomes 10 comma 15. So let me check which one is the correct answer. Option A is correct here, so that's fine. Okay, so the answer is option A. Great. So let's move on to the 8th problem. I think someone also raised an issue related to this, and yeah, I think the correct option was missing from this problem. So yeah, that was indeed an issue. So let me quickly solve this. So it's min of, just min of 2x plus 3y plus z subjected to x squared plus y squared plus z squared equals 1 x y z. I think I've written next problem. Okay, let me erase it. Min of z equals x squared plus y squared plus z squared. Okay, so this is capital Z. So let me clearly write it. Capital Z subjected to 2x plus 3y plus z equals 14 and xy greater than equals 0. So solve this. Solve the above optimization problem by method of substitution. Okay. So the options are A is star, comma y star, comma z star plus 5, 10 minus 1. B is x star, y star, z star equals 110, comma 3. C is x star, y star, z star equals 10, comma 2, comma 2. D is x star, y star, z star equals 239. So this is the wrong option. That should have been something else. Anyway, let's do this. So what you have here is that capital Z okay, capital Z is x squared plus y squared plus z squared. So take one of them. So 2x plus 3y plus z equals 14 is given, and xy relations are given. So you can take z equals 14 minus 2x minus 3y. So your capital Z becomes x squared plus y squared plus 14 minus 2x minus 3y whole square. And you can take the gradient, and your constraints are x, y are greater than or equal 0. Okay, so let's take the grad of this capital Z. So first with respect to x, so that's 2x plus 2 times 14 minus 2x minus 3y times minus 2. This is with respect to y. 3. Okay, so this becomes 2x, that's 20, minus 4 times y minus 6 times. Okay, now if you simplify it, this becomes 10x plus 12y minus 56, and this becomes 12x plus 20y minus 80. Okay, this you can set to 0, 0. You can also take the Hessian matrix, so that will give you 10. This is 12. This is 12. This is 20, and the determinants are like greater than 0. So this is positive definite. So you are indeed doing a minimization problem, and this is fine. Now let's get back here and solve these two equations. So 10x plus 12y equals 56, and 12x plus 20y equals 84. So what you can do, you can simplify it. This is 5x plus 6y equals 28. This is you can divide it by 4 actually. So this is 3x plus 5y equals 21. So you can now multiply with 5. 25x plus 30y equals 140. This becomes, multiply it by 3. 6. So that's 18x plus 30y 26. Therefore, just subtract those two. 7x equals 14. X is 2. That means 10 times 2 plus 12y equals 56. That means your y is 3, and your 2x plus 3y plus z equals 14. So that means your z is 1. So the final answer is x star y star z star equals 2, 3, 1. But none of the options are correct. But the closest one was option D. 2, 3 and 9 was given, so there was a typo. None of the options are correct. So raise this issue. Discussion form. Alright, so that was all about the 8th problem. Let me solve the last two problems, which is using the Lagrange's multiplier method. So I'll just start that. So I'll just write down the problem and I'll start with that soon. So let me write down maximize 2x plus 3y plus z subjected to x squared plus y squared plus z squared equals 1, x, y, z greater than equals 0. Solve the above optimization problem by Lagrange's multiplier method. Option A is star y star z star by root 14 2 comma 3 comma 1. B is x star, y star, z star, 1 by root 14, 3 comma 2 comma 1. Option C is x star, y star, z star, 2 comma 3 comma 1. Option D is x star, y star, z star, 1 by root 7, 3 comma 1 comma 2. So I'll solve this in a minute. So I'll just take a break and solve. Okay, so let me solve this problem now. So let me write down this again. So you can convert it into a minimization problem so that you can directly apply. So min of minus 2x minus 3y minus z subjected to x squared plus y squared plus z squared equals 1, x, y, z greater than equals 0. So you can put everything together. So you can just put Lagrange multiplier as or the Lagrange function as minus 2x minus 3y minus z plus lambda times say 1 minus x square minus y square minus z square. Okay, you can take it the partial with respect to x, so that's minus 2 minus 2x times lambda del L del y, that's minus 3 minus 2y times lambda del L del z, it's nothing but minus 1, then it is minus 2z times lambda. So from here you can write x equals to minus 1 by lambda, y equals minus 3 by 2 lambda, and z equals minus 1 by 2 lambda. And obviously you also have del L del lambda equals 0, so that's 1 minus x squared minus y squared minus z squared equals 0. You can put this values now. So it's 1 by lambda squared plus 9 by 4 lambda squared plus 1 by 4 lambda squared equals 1. So multiply this by 4. So 4 lambda squared equals 14. Lambda squared equals 7 by 2. And the lambdas needs to be negative here because x, y, z are greater than equals 0. So lambda here is minus root 7 by 2. Now we can get x star, y star, z star. So x was minus 1 by lambda. So this becomes minus 1 by lambda. Okay. Yeah, so this becomes root 2 by 7. Y star becomes, this was minus 3 by 2 lambda. And z star is minus 1 by 2 lambda. So this x star, you can also write it as, and take 1 by root 14 as common, and this will be times 2. Here also you can take okay, so it was lambda was in the denominator, so this should be root 2 by 7. Here also it should be root 2 by 7. Okay, so this becomes uh, 1 by root 14 times 3. This becomes 1 by root 14 times 1. So therefore x star, y star, z star is 1 by root 14 times 2 comma 3 comma 1. So I think option A is the correct answer. So no issues with this problem. Okay, option A is the correct answer. So that's the 9th problem. Then I'm left with only one problem for today, and then probably I'll just briefly wanted to discuss the assignment 10 problems, but no one has joined and no one has doubts, it seems. I think I'll discuss it next week. Okay, so let me write down the problem 10. This is again a similar problem. So maximize z equals 50x minus 2x square minus xy minus 3y square plus 95y, subjected to x plus y equals 25, xy greater than equals 0. So it will ask you to get the Lagrange multiplier value actually. Solve the above optimization problem by Lagrange's multiplier method. And find Lagrange's something went wrong. I hope everything is saved. Yeah, it automatically went off. Looks like it's okay. Okay. There is some issue. It's not going down. Let's reopen. Okay, and find Lagrange's multiplier lambda star. Okay, so this is the 10th problem. Option A is star equals -5. Option B is lambda star equals -15. C is lambda star equals 5. D is lambda star equals 15. Okay, so let me solve this problem. Okay, so first, what you have to do to convert it into a minimization problem. So let me write down this min of -50x plus 2x squared plus xy plus 3y squared minus 95y. Okay, so subjected to x plus y equals 25, xy greater than equals 0. So let me write down the Lagrange function first. So this is of two variables only. So we'll just quickly write this down. Okay, so plus lambda times 25 minus x minus y. So this gives me del L by del x minus 50 plus 4x plus y minus lambda. Del L del y is x plus 6y minus 95 minus lambda. This gives me 4x plus y equals 50 plus lambda, and this gives me x plus 6y equals 95 plus lambda. Right, and you have del L del lambda equals 25 minus x minus y equals 0. These are also equals to 0. Did I write those in the previous problem? It should be equal to 0. Okay. Now, what you have to do, somehow you have to find the value of lambda from here. Okay. So what you can do, we can express x and y in terms of lambda and then solve this. So this is let's multiply the first equation by 6. This is 24x plus 6y equals 300 plus 6 lambda. Okay, so that means 23x equals 205 plus 5 lambda, and your x is 205 plus 5 lambda by 23. That gives you your y. So 820 plus 20 lambda by 23 plus y equals 50 plus lambda. So y is 23. So 330 plus 3 lambda. Okay, so x plus y gives you 555. Sorry, not 555, it's 535. 535 plus 8 lambda by 23 equals 25. So 8 lambda equals 40 and lambda equals 5. So lambda star is 5 as the answer. So let's see. Yeah, option C is the correct answer. Okay, so that's all about the week 9 assignment. Okay. Now I can start with related discussions to week 10 assignment. I have some 45 minutes left, but I'll just wait for a few more minutes to see if anyone joins, and then I'll discuss it, because there is not much to discuss here because the problems are anyway not that difficult. Okay, so yeah. Okay, so I'll quickly discuss the problems that you will find in assignment 10. So problem 1 is suppose minimization of fx subjected to some gx less than equals 0 and x greater than equals 0. So you have to comment on the directions of del f and del g. Okay, so I think this is discussed in the class. So directions with respect to at the optimal point. Okay. So I can tell you something that when you write down the Lagrange function, so let me write down. So it's x and suppose some lambda and then you can have some mu. Just quickly I'll just check everything. Or you can just have it as suppose lambda. And then you can have it as fx plus lambda 1 times gx. And then you also have this x greater than equals 0. So you can also add lambda 2 times. So yeah, minus x. Then what you can do, you can take respect to that optimal point. So del L, del x is nothing but so grad of f plus lambda 1 grad of gx minus lambda 2. So what happens at the optimal point, you can comment on that. So from complemented slackness, this condition happens. So if x is 0, then lambda 2 may or may not be 0, but if x is non-zero, then you know for certain that lambda 2 will be 0. So based on that, you can make some comments here. And yeah, so I think you will be able to solve this problem. So whether it is parallel, perpendicular or oblique, those kind of things. So I'm not going into the details of it. Okay, so second one is minimize fx subjected to some g by x less than equals 0, x greater than equals 0. So gjx is suppose the active constraint. Then what is this S transpose gj? Okay, so this has been asked, and also this is discussed in the class. You won't find any issues with this. Then so S is a feasible direction here. For the third problem, S is a descent direction. Then what happens to S transpose delta F? So that is being asked. I think you'll also be able to answer this. Okay, so the fourth problem is having some issues with feasibility, but anyway, the idea is actually I won't be solving it today. So suppose I am picking x plus 5y subjected to some x squared plus 25y squared minus 10 less than equals 0, xy greater than equals 0. Actually, let me make it as 25. Okay. Then you have to find, first you can find the gradient. So grad of x, y is 1 and 5. And then your s is something that is given. So s is descent direction, but now you have to calculate this. And based on that, you have to check which s is the descent direction at that point. Okay. So the gradient doesn't change at any point, so I think you'll be able to solve it. For the next problem also, I think there is again related to feasible direction. Feasible direction, yes. So I think this problem you have to check whether the options are correct or not. Correct or not. If not, there is an issue. And also for the fourth problem, there could be some feasibility issues I think you may encounter. So I think there is some issue with both of this. And also probably problem 9 and 10 is also having some issues here if I remember correctly. So the sixth problem is yeah, it's a simple theoretical problem. So it's a sine of lambda I. That's fine. Seventh one is, so it's the KKT condition. Necessary KKT conditions are sufficient. Okay. So it's just based on KKT conditions. You have to also check for convexity. Cities and all. So I think this is again directly from the class. Then eighth one is also related to the complementary slackness. Okay. So directly from the class. Then ninth problem, somewhat interesting, but I think options might not be present. Check whether the options given are correct or not. So it might be a maximization problem, I'm not sure, but I'm not solving it today. But if these issues come up, you can always raise it to the discussion forum and we'll discuss it next week. You probably will solve similar problems related to this next week. So 10th problem, the constraint x plus y less than 2 might be wrong. Try with x plus y less than equals 4. Okay, so I'll just say raise the issues in the discussion forum. Okay, to give an example, the main thing here is that the theoretical problems you'll be able to answer, I think. So the Lagrange function is the key thing. So it could be a function of x, y, lambda. So suppose f of x, y plus lambda 1 times minus g1 of x, y plus lambda 2 times minus g2 of x, y and so on. And then you have to just set del L del X to be 0, del L del Y to be 0. But here you need not set del lambda 1 by del lambda 2. So the del L del lambda 1 by so those things need not be 0 because these are inequality constraints. But complementary slackness also gives you this condition. And you have the primal and dual feasibilities. So those lambda 1, lambda 2 is distributed universal to 0. So these things you have to keep in mind to solve the problems next week. So I'm almost 1.5 hours done, and I don't have any new problems to, I think, solve. And no one is here as well. So I'll just wait for half an hour because anyway the time is still 5 p.m. But yeah, I don't think anyone will join, and I don't have anything extra to discuss. I've already solved 10 problems of previous week, and this week's discussion is already done. Okay, if you have doubt, you can ask later in the discussion forum. So I'll stop for now, and yeah, if anyone joins and asks questions, I'll answer. Otherwise, I'll log off around 5. Thank you. Okay, so it's 5 p.m. almost. So since no one has joined, I'll close this session. Hopefully, I've discussed everything, and the week 10 assignment, I'll be discussing it in the next week's session. Yeah, so and if you have doubts, you can post it into discussion if you want. Okay, thank you all. See you next week.